Module 16, Malware Analysis. Welcome to this tutorial on malware analysis. Malware poses a significant threat in the digital landscape, and understanding its behavior is essential for effective cybersecurity. In this video, we will explore the field of malware analysis, including performing static analysis of a provided malware sample to identify its behavior and potential indicators of compromised IOCs. We will also engage in a hands-on lab where we use virtualized environments or sandboxing tools to analyze the behavior of malware samples and document their functionality. Let's begin by discussing the techniques used to perform static analysis on a malware sample. Static analysis involves examining the characteristics of a malware sample without executing it. Some techniques used in static analysis include 1. File analysis. Analyzing the file attributes, such as file type, size, and file header, can provide initial insights into the nature of the malware. Identifying specific file formats commonly associated with malware, such as executable files, X or script files, BAT, VBs, is an important step. 2. Code analysis. Examining the code structure, such as disassembling or decompiling the binary, can reveal important details about the malware's functionality, algorithms, and potential vulnerabilities it exploits. Tools like disassemblers or decompilers aid in this process. 3. Behavioral analysis. Analyzing the behavior of the malware, even in a static state, can reveal its intended actions, such as network communication, file modifications, or registry changes. Understanding the potential impact of the malware on the system is crucial for identifying IOCs. Now, let's explore the hands-on lab exercises in malware analysis. Hands-on lab exercises allow us to observe the behavior of malware samples in a controlled environment. In these exercises, we will focus on 1. Virtualized environments. Using virtualization software, we can create isolated environments to run malware samples safely. By monitoring system activities, network traffic, and file system changes, we can gain insights into the malware's behavior without risking the host system. 2. Sandbox Analysis. Sandboxing tools provide a controlled environment for executing malware samples. They allow us to observe the malware's behavior, capture network traffic, and analyze its interaction with the system. This helps in identifying malicious activities and potential IOCs. 3. Documentation. It is essential to document the findings during the analysis process. This includes recording observed behaviors, analyzing network traffic captures, and identifying potential IOCs. Proper documentation enables effective reporting and aids in future investigations. Malware analysis is a critical component of digital forensics, allowing us to understand the behavior and potential impact of malicious software. This tutorial has provided an overview of static analysis techniques, including file analysis, code analysis, and behavioral analysis. The hands-on lab exercises provide practical experience in analyzing malware samples within controlled environments. In the next tutorial, we will delve into dynamic analysis techniques, where we analyze malware by executing it and observing its runtime behavior.